Thank you, everybody, for attending OpenSearch today. As Dotan said, my name is Andrew Ross. I'm a principal engineer at AWS. And I spend a bunch of my day job doing maintainer work in the core OpenSearch repository. I'm also honored to be elected as the chair of the OpenSearch Technical Steering Committee this year. I'll talk a bit more about that later. Today, I'm going to talk about OpenSearch since we joined the Linux Foundation, but really, I'm here to talk about community-led innovation. When OpenSearch joined the Linux Foundation 13 months ago, a lot of things changed. We launched the OpenSearch Software Foundation as a nonprofit organization under LF to support the project and its software. This caused a vendor-neutral approach to how the project was managed and provided building blocks for sustainable, long-term growth. It also caused over a dozen companies to join the foundation. A vendor-neutral and community-driven approach quickly leveled the playing field for contributions to the open source project, and we started to see results right away. There were three main benefits upon joining the Linux Foundation. The first was a move to open governance. This means a model where decision-making is transparent and inclusive. The second was open collaboration. If we work together and work in public, we'll build and grow the project successfully. And the last is really the result of the first two, and that's to accelerate innovation. When more contributors from more organizations start betting on OpenSearch, innovation will speed up and compound over the long term. When we talk about open governance, we mean community-driven, community-led, and independent. And there's two specific examples I want to talk about, and that's the governing board and the technical steering committee. First, guiding the foundation is an elected governing board. The board is drawn from organizations who have committed to support the foundation financially, which helps OpenSearch grow and facilitate events such as this one. I'm honored to work with stakeholders from AWS, Aaron, DataStax, SAP, and Uber to help oversee the work of the foundation. Next, I want to highlight the Technical Steering Committee, or TSC. The TSC is chartered to lead the technical direction of the project, and it's playing a vital role. Membership in the TSC is designed to recognize technical leadership and contribution. It's based on merit with yearly elections. Each member serves a 2-year term, so half the committee is up for election every year. And in fact, we just completed, on our first anniversary, we completed our first elections. And the result is a more diverse committee than ever. The 15 members are representing 11 distinct organizations. I'm really looking forward to working with this group going forward. I also want to briefly introduce technical advisory groups, which are a part of the TSC. Tags are specialized groups that focus on a particular technical domain within OpenSearch, and each tag brings together contributors, maintainers, users, really any expert that has expertise in the particular domain. The purpose of tags is to enable deep dive conversations about domain-specific challenges. Each tag operates openly. They hold public meetings, they maintain their own roadmaps, and they document their decisions transparently. Tags are a key mechanism for the TSC to scale its governance. Not every discussion has to happen at the TSC level, and the TSC doesn't necessarily have expertise in every single domain. We currently have 2 tags right now. The first is the build tag, and it's focused on the health of the OpenSearch infrastructure and the various repositories. It does things like guiding repository management and aligning project standards across the 120 plus repositories we have within the organization. They also provide recommendations to the TSC. And second is the observability tag, which champions the strategic direction and technical guidance for observability solutions within the OpenSearch ecosystem. If you're interested in learning more, check out the Technical Steering Committee GitHub repository. And in fact, we have currently in flight are 2 more tags that have just been proposed, the security tag and the search tag. If you're interested in learning more or potentially joining and contributing, again, check out the issues on GitHub and join the conversation. Open collaboration is a driving force behind OpenSearch, and you can see it in the numbers. The big number I want to highlight here is that OpenSearch has gone from number 70 to inside the top 20, I think number 19 right now, of all Linux Foundation projects ranked by number of contributors. These numbers point to a growing, vibrant open source ecosystem. Next, I want to dive into some specific examples of contributions in the last year or so. And these things have one key thing in common. A company needed OpenSearch to do something better or do something it didn't do before, and so they went and implemented it. And the best part, it's open source, so it all came back to the project and the entire community benefits. First, I want to talk about Uber. Uber joined the Open Source Software Foundation early on and started making a difference quickly. One of the first big issues they tackled was they wanted a native gRPC API in OpenSearch. The folks at Uber actually put on a great presentation here that you can find on YouTube at this QR code. They go into a ton of detail, but I want to dive into this just a little bit more. Uber runs massive scale search infrastructure, powering their mission-critical services. They handle thousands of queries per second, and they ran into some challenges with the existing HTTP JSON-based protocol. First, there were some inefficiencies with the text-based protocol, particularly with large payloads, and they needed better data transmission efficiency as their scale continued to grow. Also, gRPC and protobuf are mature technologies, and they had a mature ecosystem within Uber of existing services that use gRPC. They wanted OpenSearch to fit into that ecosystem natively, and so they worked on adding this gRPC API. In order to implement this, Uber leveraged OpenSearch extensible architecture to build gRPC as a separate module. This has several benefits. First, it isolates the gRPC-specific dependencies into its own module, so that other plugins and modules within the ecosystem that may have different versions of some of those same dependencies wouldn't have conflicts. Second, it allows gRPC to run alongside the existing JSON-based API. And this had a couple of benefits. And one, that it allowed gRPC to focus on implementing the most performance-critical APIs first, while all the other APIs would still be available. And it also enabled the feature to be purely opt-in for use cases that did not need gRPC. They don't have to worry about it. And the results are impressive. For bulk ingestion, they saw a 15 to 40% latency improvement. And for batch ingestion jobs, Uber has this Spark infrastructure that runs these as part of their fraud detection system. It runs these batch jobs, and it dropped from 3-hour runtime to under 2 hours, a 30% reduction. And today, gRPC is the default protocol for all their OpenSearch batch ingestion at Uber. And the team is not done innovating here. You can find a meta issue at this QR code that details all the future work they have planned to continue to improve gRPC within OpenSearch. If you're interested in learning more, please do take it out, take a look at that. And if you're interested in contributing, it's all open source, so that's the place to look and get started. Uber did not stop innovating with gRPC. In fact, while a request response style API was a requirement for many use cases, other use cases required something entirely different. Enter pull-based ingestion. Again, the Uber folks did a deep dive into this at a previous OpenSearch Con, and you can find that presentation here. The push-based ingestion model of OpenSearch can be challenging at high scale. If a temporary surge exceeds the capacity of the cluster, the clients will start seeing failures. And that can be complex to manage that backlog. Additionally, Uber had a multi-region setup that already depended on Kafka for the cross-region replication. And integrating a push-based API into that system had some challenges as well. To solve these problems, Uber developed and contributed a new feature that was released in OpenSearch 3.0 called pull-based ingestion. Instead of pushing data into OpenSearch with request-response style APIs, instead, OpenSearch connects directly to a streaming system like Kafka or Kinesis and pulls the data directly. Pull-based ingestion was implemented by introducing a new generic ingest engine into OpenSearch that implements the core of the business logic. The engine also introduces a new plugin interface to avoid coupling OpenSearch directly to any particular streaming technology. We have implemented plugins for both Kafka and Kinesis that allows you to use either of those technologies as the source for your data to pull into OpenSearch. There's even a file-based ingestion plugin, which is kind of neat, but it's mainly useful for testing. It allows testing the system without having external dependency. But there's been some interesting discussions around other use cases for that as well. By developing pull-based ingestion, Uber turned its search infrastructure into a self-regulating, resilient, cloud-native system. And the best part, they shared that innovation with the entire community. And a side effect of all this great work is that Uber has now added 3 maintainers into the project. So not only has the product been enhanced by adding these great new features, but the project itself has been enhanced by adding these maintainers who will continue to help out, implementing new features, fixing bugs, responding to issues, all the things that maintainers do. Many other partners and organizations have made valuable contributions, and I want to briefly highlight a few of those as well. SAP and SAS collaborated on adding FIPS compliance to the software, which is a requirement for many use cases that work with the United States government. Intel added Z-standard compression that offers some performance improvements, both in terms of CPU utilization and in terms of improved compression ratio for many use cases. They also added some SIMD optimizations to vector search. NVIDIA collaborated with us to enable GPU-based vector index builds, which offers some amazing performance improvements for large-scale vector workloads. ByteDance has been deeply involved in the project. They have several maintainers across a few different repositories, and they've been involved deep into the core engine as well, such as making some improvements to the segment replication protocol. DataStax is adding a JVector engine to vector search, which is a pure Java implementation of vector indexing in search. DTEX has been involved in the OpenSearch dashboards for the past 12 months or so, making many improvements there. Apple has also contributed many enhancements and bug fixes. And they're working on some additional improvements to PPL in the SQL plugin. I'd like to take a moment to thank all of our member companies and all these companies that have started building with OpenSearch. I've highlighted contributions from a lot of organizations, but I also want to emphasize that the OpenSearch project is open to contributions from anyone who is interested in collaborating. I know it can feel daunting to get started as a newcomer. It's a large, complex project. So I want to provide a few tips on getting started. First, find an issue that's labeled with this good first issue. These are issues that maintainers think are fairly self-contained, and then a newcomer is likely to be successful with implementing. Another key, no problem is too small to fix. If you see a typo, an unused variable, a problem with the documentation, please do fix it. Again, no problem is too small. Everybody has to start somewhere. And the way that you build visibility and credibility with the community is by doing the work. So again, nothing is too small to get started. And along those same lines, open a PR. Pull requests are how we do a lot of the work in open source. So again, nothing is too small. Find a problem, open a PR, getting familiar with the whole pull request workflow and how the software builds, all the testing and quality checks is really important. And finally, join the conversation on Slack. Many users, contributors, maintainers are on Slack. There's many different channels depending on the domain, and Slack is a great place to get started. Before the next speaker comes up, I want to take a few minutes and highlight our latest release, which is 3.3. And that's from just a couple of weeks ago. 3.3 was a large release in terms of features and overall number of changes to the platform. The QR code here will take you to the release blog, which has all the details. But I'm going to spend a few minutes on some of the most exciting improvements. OpenSearch dashboards reached a true milestone with the release of 3.3. The user experience has been rebuilt with a new discovery workspace experience, allowing people to build and execute complex commands a lot more easily than they used to be able to. Ask a question in text, and the discovery experience will construct a query for you. The new experience brings log analytics, distributed tracing, and intelligent visualizations into a single workspace with auto visualizations, AI-powered PPL query construction, an interface for traces, and more. The new React Flow library specializes in diagramming networks and drag and drop interactions for better use. Apache Calcite has also become the default query engine for the piped processing language capability, or PPL. With it comes over 15 new commands previously unavailable in OpenSearch. In the AI category, we had another huge release. We introduced general availability for agentic search, which allows natural language questions to be asked of your data. The tool maintains context across conversations and allows people to gain insight from their data without having to know how to construct complex DSL queries. Along with that, agentic memory is a persistent memory system where AI agents can learn, remember previous conversations and interactions, and reason across those conversations. This results in a more context-aware AI agent that answers questions more fully. On the performance front, 3.3 has incorporated the seismic algorithm that delivers search latency improvements up to 100 times for neural sparse searches. Building on performance gains, we added batch processing support for remote inference calls, and the batching mechanism helps reduce GPU utilization by sending results in a single larger call, a larger body of work, as opposed to a bunch of smaller requests. This depends on your workload, but benchmarks are showing improvements between 2 and 14 times with batch inference. A few other notable improvements to mention. gRPC, which I mentioned earlier, it's expanded support in terms of with 7 new query operations. The protobuf Python libraries are published to PyPy as well. Maximal marginal relevance, or MMR, was added. MMR tries to balance the most relevant information possible without offering redundant results. It's a native integration into OpenSearch and is most useful for things like recommendation systems. The aim of MMR is to get a more well-rounded set of answers to any given question. The Query Insights dashboard has been updated with workload management tools, allowing cluster admins to monitor and analyze live queries. This benefits in situations where you need to identify performance problems or examine resource utilization in general. This can really help if you're investigating a performance problem and you need to isolate a particular query that's causing problems. This is a great tool to help with that work. And before I wrap up, I want to end with my favorite slide here. And I've talked about a lot of great new features that have been added to the platform, but the project remains focused on building the most performant search engine, which can be seen in this trend of continuous improvement since the 1.0 release. And note the gains are so big on this graph that the y-axis is a logarithmic scale. So some of these gains are, orders of magnitude gains. In fact, across the various query types of the big 5 workloads shown here, searches are on average 10 times faster. And you can see that dotted line in the middle is the geometric mean of all these key query types. And by that benchmark, latency has dropped from 160 milliseconds in the 1.x line to just 16 milliseconds in the latest releases. Lastly, thanks to all of you for showing up today. OpenSearch got to where it is today with the help of people who came to work on the project and came to these conferences and care about search technology. I'm sure you'll have a great time today and make the most of all the sessions. Thank you.